All right, today we're going to learn how to work in scientific notation again. You said we learned that last time when we were multiplying in scientific notation. You're right. But if you can multiply in scientific notation, you could also divide in scientific notation. And again, why would you want to divide in scientific notation? To get rid of all those zeros. Because 0, 0, 0, you could easily have one too many zeros or one too small, less zeros if you had extremely large or extremely small amount. So if I had a problem like this, 72 billion divided by 8,000. Again, I could do this by hand, but I would have to make sure that the zeros were lined up right to get the exact right answer. And one too many zeros or one too little zeros could make a giant difference in your final answer. So instead of doing it with the zeros, first of all, write them in scientific notation. That's so you can get rid of all the zeros. How can you do that? Place the decimal behind the first natural number, drop the zeros, that gives you 7 2/10. Count how many places between where it was and where it was put. That's 3, 6, 9, 10 places. So that's times 10 to the 10th. Again, same thing here. Put the decimal behind the first natural number and drop the zeros and you get the whole number 8. Count how many places between where you put it and where it was. 1, 2, 3 places times 10 to the 3rd. And as we talked about last time, this looks way more difficult than this does. It looks way more difficult, but it's not. Okay, the truth is this is way easier than that. But only if you do it in segments. Remember when you were multiplying, you multiplied the decimal by the decimal and the power of 10 by the power of 10? Well, I'm going to do the same thing here. I'm going to divide the decimal by the decimal and the power of 10 by the power of 10. Now this is very easy if you know your times table, because you're dividing a whole number into a decimal, so just bring the decimal up. 8 goes into 72 9 times 8 is 72. So this answer is 9/10. Now this looks hard, but it really isn't, because 10 to the 10th power means 10 times 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 10 divided by 10 times 10 times 10. And again, that's a lot of tens. But if you just simplify and cross out 3 of the 10s with 3 of the 10s, that's kind of like simplify before you multiply. You're left with 10 times 10 times 10 times 10 times 10 times 10 times 10. How many 10s? 7. So that would be 10 to the 7th power. And again, what's the easy way to find this answer without doing any of this work? The easy way is to subtract exponents. And we learned that before. If you're dividing with the same base number, if you're dividing powers with the same base number, you subtract exponents. So it's 10 minus 3 is 7. So this is my answer in scientific notation. But it really isn't my answer in scientific notation because the decimal's in the wrong place. If you want the decimal in the right place, you have to move it behind the first natural number, not in front. So instead of 9/10, I want to make it 9. Now, I moved it 7 places to the right from here, but if I already moved it 1 place right, I don't have to move 7 places right, I only have to move 6 places to the right. So the right answer is 9 times 10 to the 6th. And you might say, but Mr. Adu, last time you raised the exponent, you didn't lower it. That's right, because last time I moved an extra place to the left, so I had to add a place. This time I moved a place to the right, so I had to take away a place. And I told you when we were talking about multiplying, the way you can tell whether you have to add or subtract, okay, is you can look at the number. If you made this number bigger, make this exponent smaller. If you make this number smaller, make this number larger. 9/10 became 9 whole things, so I made this number bigger. So 10 to the 7th becomes 10 to the 6th. So it's basically the same idea as multiplying. Do it in parts, and it makes it a lot easier. But again, most people can write this into scientific notation like this with no problem. And most people can divide these and get this with no problem. The place most people have the most trouble is changing this into that. In scientific notation, the decimal must be behind the first natural number. All right. By the way, since I gave you examples with extremely large numbers, let's look at an example with extremely small numbers. What if I had something like this divided by something like this? By the way, this is tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. That's 140, 400 millions, an extremely small number. And this number, tens, hundreds, thousands, 10,000, 100,000s, is 900,000s. So if I want to divide 144 millions by 900,000s, the easiest way, and avoid all the zeros, is write them in scientific notation. What would this become? Put the decimal behind the first natural number, drop the zeros, gives you 1 and 44 hundredths. Count how many places between where it was and where you put it. 1, 2, 3, 4, 5, 6. So times 10 to the 6th, but not times 10 to the 6th, 10 to the negative 6th. Because I don't want to move 6 places to the right, I want to move 6 places to the left. And to move it in the opposite direction, you have to make the exponent the opposite. So the opposite of moving 10 places to the right is 6 places to the left, so it's 10 to the negative 6. Again, here, place the decimal behind the first natural number, drop the zeros, you get the whole number 9. Count how many places, 1, 2, 3, 4, 5 places, so that's times 10, but not 10 to the 5th, 10 to the negative 5th, because again, I want to move it to the left. So now how would I do this? This looks harder than this, but it's way easier. Do it in parts. Okay, the first part I have to do is 1 and 44 hundredths divided by 9. Bring the decimal straight up. 9 goes in 14 once. Remainder 5. 9 goes into 54 6 times. Remainder 0. So that's 16 hundredths times here 10 to the negative 6 divided by 10 to the negative 5th. Remember, we're going to subtract exponents. By the way, when I subtract a negative 6 minus a negative 5, I change it to plus a positive 5, and I get 10 to the negative first. And again, you're dealing with subtracting integers, so you have to make sure you change it to addition. 90 to 95% of mistakes people make in algebra are sign mistakes. Most of them deal with subtraction. Same thing here. By the way, this is my answer, but it's wrong because it's not in scientific notation. To put it in scientific notation, you got to move the decimal behind the first natural number, 1 and 6/10. By the way, I made this number smaller, okay? So I have to I made this number bigger. 16 hundredths became 1 and 6/10. I made this number bigger, so I have to make this number smaller. And to make this number smaller, I actually, subtract 1 from a negative 1. And a negative 1 minus a positive 1 becomes a negative 1 plus a negative 1. So your answer is actually 10 to the negative 2nd. I can't tell you the number of people who would make this 10 to the 0 power, because 90 to 95% of mistakes people make in algebra are sign mistakes, and most of them deal with subtracting. And a negative 1 minus a positive 1 is really a negative 1 plus a negative 1. Now this would be your final answer. So again, this is the last thing that we're going to learn, okay? So I wanted to make sure you understood about all this stuff in scientific notation. By the way, I promise you, you will use this stuff when you go to high school. All right, so please make sure you learn it. By the way, you'll use it in Algebra 1, but more importantly, you'll use it in high school science classes, both in physics and in chemistry. You use this. Chemistry, you use it for extremely small numbers. In physics, you use it for extremely large numbers and sometimes extremely small numbers. And sometimes you have extremely large numbers and extremely small numbers. which means the power of 10 might be positive and the other one might be negative, which is why, again, you need to know about integers. So again, good luck, and I hope you understand this.